डेटा में से एक लार्ज पोर्शन को रिजर्व कर दें फॉर टेस्टिंग एंड नॉट यूटिलाइज दैट पोर्शन इन द ट्रेनिंग, तो हमारे पास ट्रेनिंग डेटा तो ऑलरेडी इनसफिशिएंट होता है। ये सारे प्रॉब्लम शायद आए ही तब थे कि हमारे पास ट्रेनिंग के लिए और मजीद पॉइंट्स हो वी कैन परफॉर्म बेटर। तो जो ट्रेनिंग डेटा अवेलेबल है ऑलरेडी हमारा क्लेम ये था, ये बिल्डिंग ब्लॉक ये था कि ये थोड़ा है, उसमें से भी हम एक पार्टीशन जो है वो निकाल रहे हैं और उसको यूटिलाइज नहीं कर रहे। तो जो मॉडल हम चूज़ करके लाएंगे या फिट करके लाएंगे दैट विल नॉट बी प्रॉपर, और द ट्रेनिंग डेटा एक्चुअली जिसका पोर्शन आपने जो सेपरेट आउट कर दिया है वो भी यूटिलाइज किया जाता है। तो यहाँ से शायद एक क्लू ये मिलता है कि हम ट्रेनिंग डेटा की जब पार्टीशनिंग कर रहे हैं तो टेस्ट डेटा बहुत थोड़ा ले लें और ट्रेनिंग डेटा ज़्यादा से ज़्यादा ले लें। बट देन द प्रॉब्लम इज कि अगर हम टेस्टिंग डेटा या वो पार्टीशन जिस पे हमें परफॉर्मेंस इवैल्यूएट करनी है अगर वो बहुत थोड़ी हो तो जो हमारी इवैल्यूएशन है दैट इज नॉट स्टेबल, बिकॉज जो कॉम्बिनेशन हमने अप्लाई किया है मॉडल का कॉस्ट का वो जिस डेटा सेट पे हम इवैल्यूएट कर रहे हैं दैट इज वेरी स्मॉल, एंड बेस्ड ऑन वेरी स्मॉल नंबर ऑफ पॉइंट्स द इवैल्यूएशन कैन नॉट बी रिपोर्टेड कि यार ये बहुत बेहतर परफॉर्म करेगी। सो वी शुड बी हैविंग इनफ टेस्ट डेटा टू क्लेम दैट the out of sample error, the estimate of out of sample error is stable. Make sense?
Yes.
So that's a trade-off. We need more training data for a better fit, but we need more testing data for better evaluation, okay, to choose better. So the trade-off is resolved by heuristic or rule of thumb. People say that okay, 80-20 rule is sufficient. If you have training data, let's take 80% of the data and use that for training, and 20% of the data use that for testing. Make sense? And then people say, okay, rotate the roles and do cross validation, for example. So make different partitions of the data, because जो data आप testing के लिए specify कर रहे हैं कि इसको हम testing के लिए use करेंगे, that particular data never used for training. उसमें जो information है that is not utilized. So हम करेंगे ये हम rotations कर लेंगे, data की partitions कर लेंगे, let's say 10 या 5 whatever, and then use one partition for testing and the rest combined test for training, and then we'll go on use the second partition for testing and the rest for training and so on. And this particular model is known as cross validation. This is a very clever trick to use each and every point for testing as well as training in different applications. Make sense?
इन सब partitions के अंदर जैसे कि हमने अलग अलग W निकाले, उनमें से 10 W निकालेंगे और उसको ऐसे नोट करेंगे।
Okay. So we will fix, for example, let's say lambda is equal to 0.5. Let's say in a particular iteration of cross validation, let's say now we are testing for lambda is equal to 0.5. Okay. And what we do, we train on X train 1 and Y train 1 with lambda, and we get a particular model that we call as W1. Okay, and then we have E out, let me call it E out 1, and that is predict X test 1, Y test 1, sorry, X test 1, that is my Y predicted, X test 1 comma W1, that will give me Y predicted, okay, and then I will compute the error, cost, YP and Y test 1. This is for one partition, okay? This is just assume I have here a loop J is equal to 1 to number of partitions. That we call it number of folds, or 10 folds cross validation partitions. Then this will go for J. And this is for one particular lambda. This is J. This is J. This is J. And this is E out J. Okay? And if you are interested in this one. Then for this particular lambda, I will exhaust all the partitions. And then at the end, I will take the E out, which is equal to average of E out J. ये जितने भी थे, A का A है, okay, average, and that corresponds to this particular lambda. And I will report lambda. I will report lambda. और आज हम देखेंगे लैब के अंदर कि ये सारा प्रोसेस कैसे करते हैं। Make sense? Is that okay? Okay. So that is these are the steps of cross validations. ये last time हमने discuss किया था. Today in the lab you will see each and everything of cross validation इंशाल्लाह in the running way. फिर हमने देखा कि actually there are 4 things to choose from: pattern class, cost function, regularizer, and the strength of regularizer. All these things have infinite priority. So it turns out that in practice, there are some pattern classes that are mostly used because of their practical merits and stuff. So this, in practice, is not very bigger set. So we can go with that. The cost function, the total error layers, I mean, you can design more and more error layers, but then you have to prove that this particular error layer has better merits than this one. So those which are actually used in practice and have very good merits and theoretical properties, these are not very, I mean, this set is not very big in practice again. Similarly, the regularizers, there are several regularizers. You can come up with your regularizer, that this regularizer is working this way or that way, but then you have to prove that this is working better than this one in this particular situation and whatnot. So in that case, there are some standard set of regularizers that people work on, and they actually, this set is not very big practically. But now, we have restricted this set to be some standard sets. We have restricted this set to be some standard sets. Okay, choose this one, that one, that's it. We have restricted this one. Then lambda should not be restricted, because lambda is something that will take care of your restriction on this set, your restriction on this set, and your restriction on this set. Because you allow lambda to flow and check everything. And lambda will somehow practically take care of that you have not utilized this model and you should have utilized this model and stuff. So it will take care of all that kind of stuff. Not threatening him practically. Make sense? So lambda is something upon which the cross validation actually practically happens. Mostly we do not iterate over different models. Mostly we fix a model, sometimes complicated one, and then let the lambda to make it simple as it should work. Mostly we work for, let's say, square error, that's it. And then let the lambda to decide what the W parameters should be to work with the square error, and so on. Make sense? Yes, no?
Yes.
So this lambda is a critical, the critical loop in cross validation is on this lambda, and this lambda actually takes care of the other approximation of the notions we have done. Yes, no? So far so good? So आज हम अपना पहला क्लासिफायर लिखने जा रहे हैं और देखेंगे कि उसकी फॉर्मुलेशन बिल्कुल वही होगी जो हमने बिल्कुल स्टार्ट वाले किसी लेक्चर में लीनियर रिग्रेशन में देखी थी. हम रिग्रेशन मॉडल को यूज करेंगे और उस मॉडल में थोड़ी सी सिंप्लीफिकेशन या तब्दीली करेंगे एंड द सेम मॉडल विल बी वर्किंग फॉर क्लासिफिकेशन. क्लासिफिकेशन यस.
लास्ट टाइम हमने लैम्डा की कुछ वैल्यू सेट की थी 0 to 100 मान के हम ये हम पहले सेट कर रहे थे लैम्डा की
Okay, there are clever ways of pinning down the reasonable lambda. I'm not saying the correct lambda, because finding out the correct lambda is almost impossible because there are different choices. The reasonable lambda, how to do that? In the first, so one way is you start from 0 and go to the very large number with very tiny steps and check for each step what is the performance of your sample. Make sense? But in that case, that loop will become very, very large and the cross validation will take a lot of time. And in reality, the cross validation is a time-taking task. Okay? This is the task that takes, I mean, most of the time in training. To answer your question, the practical tricks are to start with the lower limit, set a high limit, and take bigger jumps. So then see in what kind of range of lambda E out was moving down and then moves up. Because that is the range in which if I more go down, if I pin down things in tiny steps, then maybe I find that reasonable lambda and then more reasonable and so on. So you set the range, and in that range take tiny steps. Then find out the range again, then take more tiny steps and pin down the reasonable lambda. And I mean that's the practical way of doing this. Yes? फर्क है रिग्रेशन में जो आपका लेबल है जिसको हम y अब तक कहते आ रहे हैं दैट इज रियल एंड कैन टेक एनी रियल वैल्यू so to speak the total number of the variety of labels is infinite, actually uncountable. Make sense? That's a regression. The classification model is for each training point you are given a label and the total number of labels are finite and discrete. But saying finite means discrete. Okay? And the usual convention is to start the labeling from 0, then the next class label it 1, the next class label it 2, 3, 4, 5, 6 and so on. Make sense? Yes. For example, OCR अगर आपने ऑप्टिकल कैरेक्टर रिकग्निशन करनी है तो आपके पास 10 होंगे digits and so these are 10 classes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and then you have 26 alphabets. Let's say all are uppercase. Let's say 26 alphabets. So total number of classes you have is 36 in that case. Make sense? And जब एक नई इमेज आपके पास आए उसके अंदर कोई कैरेक्टर है तो आपका टास्क ये है कि उस कैरेक्टर को लेबल असाइन करें कि ये 2 है 3 है ये B है C है what. So that is these are 36 classes. सही है? And your goal is to come up with a function. उस फंक्शन पे हम वो फीचर वेक्टर डालेंगे several features and it should give me the class label. Make sense? Face recognition. अगर इस क्लास के लिए मैं फेस रिकग्नाइजर बनाना चाहता हूँ और इस क्लास में जो टोटल लोग अभी बैठे हुए हैं नॉर्मली देयर 35 और मे बी 40 तो योर टोटल नंबर ऑफ क्लासेस आर 40 फॉर एग्जांपल इफ देयर आर 40 स्टूडेंट्स हियर ओके एंड मे बी आई स्टार्ट बाय सेइंग Salman has ID 0 which is the class ID class label, this person has ID 1 which is the class label 1 and so on. So I may take multiple images or feature vectors, multiple feature vectors I mean of Salman, multiple feature vectors, this and that, and so on. So we have 40 classes. Goal is given a feature vector, our model should give us one of the labels, and the labels start from 0, 1, 2, 3 till 39. Yes, no? Make sense? That's the problem. So,
सर हमने अगर डाटा लिया जैसे नंबर ऑफ पेयर्स का आपने कहा अगर उनका डाटा आ रहा है तो उसमें से हमारे पास मल्टीपल वो आते हैं डाटा आते हैं किसी का डिफरेंट फॉन्ट होता है या किसी का डिफरेंट साइज होता है तो हर एक को हम अलग से क्लास बनाएंगे उसकी या एक ही तरह की होंगी.
that depends. अगर आपने एक ही कैरेक्टर के को डिफरेंट फॉन्ट्स में क्लासिफाई करना है that's another classification problem. For example आपके पास एक कैरेक्टर है A और A के साथ एसोसिएटेड है लेट्स से 5 डिफरेंट फॉन्ट्स तो फिर A को क्लासिफाई करना है 5 में से किसी एक में that's another classification task. So उस केस में होगा ये कि आपको हर फॉन्ट में A की काफ़ी सारी एग्जांपल्स चाहिए होंगी फॉर ट्रेनिंग. सो फॉन्ट 1 के अंदर A की काफ़ी सारी एग्जांपल्स, फॉन्ट 2 के अंदर A की काफ़ी सारी एग्जांपल्स, फॉन्ट 3 के अंदर A की काफ़ी सारी एग्जांपल्स एंड सो ऑन. एंड देन योर टास्क वुड बी कि नया जो फीचर वेक्टर आ रहा है that is feature vector of A of one of the fonts and your model will tell कि this feature vector has one font. That's your classification.
तो ये सब फॉन्ट्स की हम कंबाइन करने के लिए इसकी कोई डाटाबेस वगैरह बना सकते हैं.
किसकी?
इन सब फॉन्ट्स को या क्लासेस जो हम बनाएंगे तो इसकी हम कोई डाटाबेस वगैरह बना सकते हैं कि मतलब काम करती है.
Yes, so that question is based on the data representation. कि ट्रेनिंग डेटा को रिप्रेजेंट कैसे किया जाता है. देखिए नॉर्मली जो ट्रेनिंग डेटा है आपका वो इमेजेस की फॉर्म में भी आ सकता होता है. फॉर एग्जांपल जैसे फेस रिकग्निशन के केस में एक पर्सन का जो एक डेटा पॉइंट है दैट अपीयर्स एज इमेज एंड वी कन्वर्ट दैट इमेज टू अ वेक्टर टू बी कंसिस्टेंट. So machine learning requires the representation of the point as a column vector. Now there is a pre-processing task to convert your data to this representation. Sometimes that conversion is straightforward, sometimes it is involved. So for example text है, data text में strings लिखनी है, I am going to this and that and that. So maybe you want to convert this string to a vector of numbers. And that's from where the machine learning will start. How to convert that, how to come up with the good features, which features are good, which are not good, I mean that is also an involved task. उसको भी देखना पड़ेगा. Sometimes I mean people just use raw features and let the algorithm decide the importance of features or derive the features and And a very new technique in the advanced technique in machine learning called deep learning actually do that. So it solves the problem of feature abstraction for you automatically, somehow automatically.
So how is classification different from regression?
Yes, so in regression, the label is, so you can think of regression as, this is completely informal, just for understanding. You can think regression as a classification problem with infinite classes. But that infinite number of classes are not countable. I mean, there are infinite sets that are countable, there are infinite sets that are not countable. So that's, but saying that regression really is a classification problem with infinite number of classes, I mean, this is kind of a nonsense statement. But for understanding, और regression use वहाँ पे होती है जहाँ पे exact label, I mean, you're not interested in the, for example, you want to predict the income of a particular person based on the age and the country जिसमें वो है. For example, there are total, let's say, K countries, और जिस country में रह रहा है एक feature इसका ये, so country ID, that's a feature, और उसकी age, that's a feature, and based on that you want to predict the income. Now income अगर उसकी है, for example, 113399, let's say, or 113399.2, या 113394, I mean, they are all different. Whereas in classes we say zero, label 0 is completely different than label 1. There is no connection in between. Make sense? Have I answered your question? No?
Yes.
सर आपने क्या कहा है कि उसमें 113399 रिग्रेशन में क्या होगा?
रिग्रेशन में जो प्रेडिक्शन है ना आपकी प्रेडिक्शन, आई मीन फॉर एग्जांपल आप फाइंड आउट करना चाह रहे हैं कि इनकम कितनी है, और बेस्ड ऑन कि आपके पास काफ़ी सारा डेटा है लोगों का, इस कंट्री में ये लोग रहते हैं, इनकी अगर इतनी एज है तो इनकम इतनी थी, अब एक नया बंदा है, उससे पूछेंगे तुम्हारी कंट्री क्या है, तुम्हारी एज क्या है, एंड वी विल गिव हिम अ प्रेडिक्शन कि यार तुम्हारी इनकम इतनी होगी, या अगर तुम इस कंट्री में हो तुम्हारी एज, या अगर तुम इस एज के हो अगर इस कंट्री में चले जाओ तो तुम्हारी इनकम इतनी हो सकती है, दैट्स इट, ठीक है. और वो जो इनकम की वैल्यू है ना, वी आर इंटरेस्टेड इन दैट वैल्यू रादर देन कि हम उस वैल्यू का ग्रुप कौन सा बनता है, एग्जैक्ट वैल्यू, वी आर इंटरेस्टेड इन दैट एग्जैक्ट वैल्यू. मेक सेंस? Whereas in classes we want to find out, for example, एक नया बंदा है, ठीक है, उसके आईज, ये दो आईज जो हैं इनके दरमियान डिस्टेंस है लेट्स से 2 सेंटीमीटर्स, उसका आईज से इस लिप का जो डिस्टेंस है लेट्स से दैट इज 3 सेंटीमीटर लेट्स से, और उसके कुछ और फीचर्स हमने रिकॉर्ड किए लेट्स से, एंड नाउ वी वांट टू से कि ही इज, आई मीन, अकरम और असलम. मेक सेंस? दैट्स क्लासिफिकेशन. Make sense? Okay, so just to differentiate more concretely, your f w xi, if it belongs to real number, then you have done regression. Okay, if your fw xi, this belongs to some set of 0, and this is classification.
बट सर हमने रिग्रेशन परफॉर्म करते हुए भी तो रिस्ट्रिक्ट कर ही दिया ना, हमने मतलब चंद जो है वो हम लैम्ब्डास की वैल्यू को बढ़ाने के लिए 20 हम ट्राई करते हैं.
लैम्बडा की वैल्यू क्या होगी? दैट्स अ सेपरेट क्वेश्चन. पॉसिबल लेबल्स क्या होंगे, यानी जो फंक्शन वैल्यू रिटर्न करेगा वो वैल्यू किस रेंज में आ सकती है, दैट्स अनदर क्वेश्चन. सो डू नॉट कंफ्यूज लैम्बडा with the label, with the predicted value. Right? One can
declined off as well. ना ये बात
ये वाला पीछे से होगी. देखिएगा
ऑन करनी है.
वो बहुत from model you pull off override, and at the end we will do something with the learned model, and it will be giving us discrete labels rather than the continuous labels. Make sense? So let's see. Okay. First of all, let me decide the model. Pattern class. Pattern class 1 degree polynomial. Well, it should be 2 degree, 3 degree, 4 degree. We will see that. Right now, it's 1 degree polynomial. Okay? Cost function. Square error. What if we use something else? We'll see that. Okay? Number 3, a regularizer. Regularizer, bridge, or econom, I mean, W transpose W source. Make sense? For lambda, we will find out through cross validation. Make sense? So this is what we are going to do right now, and we will see how to convert this to classification. थोड़ी सी चीज़ें मैं डिस्कस करता चलूँ. Right now जो मैं classification आपको बताने जा रहा हूँ, that is a binary classifier or binary classification. By binary classification, I mean the total number of classes are just 2, 0, 1. Now you can think of the real situations. In the real situations, the total number of classes you have, they're actually much more than 2. For example, in face recognition, you have 40 classes. In OCR, you have 36 classes, and I mean many more. So, and that kind of classification is known as multiple classification or multi-classification. उस classifier को कहते हैं multi-classifier. Clear है? मैं भी आपको classifier build करने से पहले बताऊंगा कि, in fact, if we have binary classifier, then we can build a multi-classifier just by using binary classifier. So basically, not all, but most of the multi-classifiers, they actually rely on binary classifiers. Not all. There are classifiers that are directly multi-classifiers. They do not rely on binary classifier. But several of those, they actually rely on basic building block, which is binary classifier. Once you have binary classifier, you can reuse it to make a multi-classifier.
Like inference is working.
Yes, yes. So I'm going to explain that thing first. I'm going to explain that, let's say we have a binary classifier. How we can go for how can we build a multiple classifier? And then we will derive one binary classifier. Make sense? And then we will be able to, whenever we introduce a new binary classifier, we'll be having a thinking how to use it to build a multiple classifier. Yes? So मैं करूँगा ये कि मैं आपको बताऊँगा कि लेट्स से मेरे पास एक बाइनरी क्लासिफायर अवेलेबल है, उसको यूज़ करते हुए मैं मल्टीपल क्लासिफिकेशन कैसे कर सकता हूँ. अगर मेरे टोटल नंबर ऑफ क्लासेस मोर देन 2 हो, हाउ कैन आई रीयूज दैट क्लासिफायर टू बिल्ड दिस टास्क. दैट्स इट. Okay, binary classification means what? I have data set, let's say x1, y1, x2, y2, xn, yn. That's my data set. And my yi belongs to 0, 1. Okay? And xi is lead dimensional vector, which has big features. Here, let's say that I have a way to get W star. I have a way to get W star using inequality. Using obviously मैं कोई क्रॉस वैलिडेशन भी करूँगा, कोई तरीका अप्लाई किया करूँगा और W star आ जाएगा such that f of W star this belongs to either 0 or 1. Make sense? Oh, sorry. F of W star x p it belongs to 0 and 1. अभी ये करना कैसे है देखिए, अभी मैं इसको बिल्कुल ब्लैक बॉक्स ले रहा हूँ। मैं फर्स्ट कर रहा हूँ कि अगर मेरे पास ट्रेनिंग डेटा हो जिसके लेवल 0 और 1 हो, तो लेट्स से आई कैन फाइंड आउट अ फंक्शन, अ मॉडल जिसको जो भी पॉइंट दूंगा वो मुझे 0 या 1 में जवाब दिया करेगा। एंड लेट्स से दिस इज अ वेरी गुड वन। लेट्स क्लियर? What if I have, let's say, 3 classes or 4 classes? How can I utilize this utility, having this utility, to build a classifier for more than 2 classes? Clear? So let's see that. ये eraser? None. Now let's say I have data with 3 classes. 3 classes. Let's say x1, y1, x2, y2, and xn, yn, where yi belongs to, let's say, 0, 1, and 2. Okay? Yes? What I will do, I will pick all the data set of class 1, and for example, I will pick all the data set of class 1, and I will pick all the data set of class 1, 2 and 3, and assume that the data of class 2 and 3 belongs to class 2. So what I will do is this, I will pick all the points of class 0. I will pick all the points of class 0. Then I will pick all the points of class 1 and 2 and relabel them to 1. Make sense? Yes. Yes? Perfect. So मैंने सारे yes मैं पिक कर रहा हूँ, इसमें class 1, 2 और 3 के points हैं। मैं क्लास 1 के पॉइंट्स एवरेज उठा रहा हूँ, उनका लेवल 0 होगा। क्लास 2 के जो पॉइंट्स हैं उनका लेवल 1 होगा, उनको मैं बार कर देता हूँ। क्लास 3 के जो पॉइंट्स होंगे उनका लेवल 2 होगा, मैं उनको भी 1 कर देता हूँ। और कहता हूँ कि मेरे पास सिर्फ 2 क्लासेस हैं, क्लास 1 और क्लास 2। मैं क्लास 2 और 3 को मर्ज करके क्लास 2 बना देता हूँ। लेट्स क्लियर? अब मेरे पास जो प्रॉब्लम है वो बाइनरी है। अब मेरे पास जो प्रॉब्लम है वो बाइनरी है। एंड व्हाट आई विल डू, आई विल लर्न W1 star by giving this kind of data, जिसमें 0 लेवल के पॉइंट्स हैं और 1 लेवल के पॉइंट्स हैं। Yes? और मेरे पास जो W star 1 होगा, वो हमेशा मुझे पॉइंट दिया करेगा 0 to 1। ये मिल जाएगा। Yes? This is step 1. Yes, no? ये समझ में आई? अब हम क्लास 1, 2 और 3 के डेटा पॉइंट्स थे। क्लास 1 के डेटा क्लास 1 नहीं, क्लास 2 और 3 को मैंने मर्ज करके कहा कि ये पूरी क्लास 2 है। तो उनके डेटा डिफरेंट होगा क्योंकि वो डिफरेंट क्लासेस हैं। अभी मैं एक स्टेप किया, तो मैं एक और स्टेप करने लगा जिससे लगेगा कि हर पॉइंट तीनों में से किसी एक में क्लास में होगा। अभी पहले स्टेप में मैंने ये किया है कि मैंने धक्के से बाइनरी क्लासिफिकेशन बना ली है, प्रॉपर बना लिया, हालांकि 3 क्लासेस हैं, मैंने उनको 2 में कन्वर्ट कर दिया। I keep 1 as it is and I merge 2 and 3. And then I learn a classifier that distinguishes class 1 with the rest, whatever the rest is. Make sense?
मतलब मैं एक ऐसा क्वेश्चन करता हूँ जिसमें मैं सभी कहता हूँ कि इस क्लास 1
अगर ये क्लास 1 का है then I'm okay, अगर ये क्लास 1 का नहीं है then it is one of the class 1 or 2. उसको मैं ले आऊँ. So I have built a model right now which अगर तो मेरे पास एक नया टेस्ट पॉइंट आता है और मेरा ये जो फंक्शन है वो कह देता है it is class 0, then I'm done, it is class 0. अगर मेरा ये क्लासिफायर कहता है कि जो नया पॉइंट है it is of class 1, then it is either of class 2 or of class 3 that I don't know because मैंने तो दोनों मर्ज कर दिया था. Yes, no. अब मुझे कोई पोस्ट प्रोसेसिंग करनी है उससे ज़्यादा. Make sense? Okay. Now step 2. Step 2. I just discard this data of class 0. I discard this. I just discard this data of class 0. I pick the data of class 2 and label it as 0. I pick the data of class 3 and label it as 1. So अब मैं class 1 को फेंक देता हूँ. अब मेरे पास दो क्लासेस हैं, class 2 and class 3. और now the problem is again of binary classification. Yes, no?
Yes.
अब मैं लर्न करता हूँ using the data of class 2 and class 3, class 0 के data को मैं यूज नहीं कर रहा. And let's say that is W star 2. Make sense? And the W star again belongs to 0. Yes, ये समझ में आ गई? अब फर्स्ट करेंगे टेस्ट पॉइंट मेरे पास आता है. टेस्ट पॉइंट इस फंक्शन से मैं पास करूंगा और रिजल्ट आता है 0. दैट मींस व्हाट? इन तीन क्लासों में से वो क्लास 1 में है. यस? अगर ये वाला फंक्शन मुझे कहे कि नहीं इट बिलोंग्स टू क्लास 1, तो अब या वो क्लास 2 में है या क्लास 3 में. तो मैं उसी टेस्ट पॉइंट को इसमें ले आऊंगा.
डन हो गया.
सही है? अब ये हम दोनों क्लासों में ट्रेन होंगे. पहली क्लास वैसे आपने स्टार्ट कर दी. अब अगर ये वैल्यू दे दिया 0, दैट मींस इट इज ऑफ क्लास 2. अगर ये वैल्यू दे दिया 1, देन दैट मींस इट इज क्लास. अच्छा, अब अगर आपके पास 4 क्लासेस हो तो आपने क्या करना है?
3.
आपने 3 लर्न करना है. अगर आपके पास 5 क्लासेस हो तो अगर आपके पास k क्लासेस हो k minus 1 such functions and you are good to go for multi-classification. It has some problem. This is not a very good way. I mean, there are a little better ways for that, but I'm not disclosing the problems. जो इसमें थोड़ी बहुत problem है, but that is something that is used, and people can just use. Given a binary classifier, you can build a classifier this way. There are other ways of building multi-classifier using binary classification. This is not just the only way, but I'm just giving you one way, and I'm forcing you to appreciate binary classifier because having binary classifier, we have a lot of power. Yes, no?
Yes.
So now we are moving towards building our first binary classifier. The classifier having 2 classes. Yes?
Yes.
Erase it. Okay, remember, we have 1 degree polynomial, cost function is squared error, vectorizer is taken off, or h, lambda we have to find out. So let's write the error function with respect to that. Help me writing error function. By the way, if this is your data point, if this is one data point, which is x1, x2, xp, if this is one data point with some label, let's say y, let's say this is first data point, this is y1, this is the second data point. I mean, this has b features, so I'm just expanding that out. It's writing in a vector form, x1, x2, xd, but now this is really a second point. So this is y2. So we have data like again x1, x2. Focus on the notation. I'm writing small subscripts for features and capitals for vectors. And then we have d and we have n. This is y. Yes? What do we mean by 1 degree polynomial? 1 degree polynomial means this. It is w0 plus w1 x1 plus w2 x2 plus wd xd. That's a 1 degree polynomial in this dimension. Yes? Make sense? That's a 1 degree polynomial representation in this convention. I mean, all the terms with degree 1 or less. Yes, no?
Yes.
Now, for ith point, for ith data point, things just become like this. Yes? Yes. Minus yi squared, that's our cost. So that's a result of the polynomial. This thing, it's a result of the polynomial. This is the result of the polynomial. And this is what the result should be. The difference in that square, that's our cost. Yes? Make sense?
Yes.
And we want this cost to be down for all the points, and then we take the average of it. That's our training error. Now we have fixed the model, we have fixed the cost function. Yes? The model is 1 degree polynomial, the cost function is square error. Plus regularizer. That's regularizer. I mean, मैं ये सारी submissions खत्म करूँगा थोड़ी देर बाद. This is regularizer. Which is actually, अगर आप W को इस फॉर्म में देखें, अगर आप W को इस फॉर्म में देखें, W वेक्टर, W को वेक्टर की फॉर्म में देखें, then sum of square of components is essentially W transpose W. W transpose W is simply the sum of the squares of the components of the vector W. Yes, no? Make sense? I'm going to erase this board. That's okay.
Yes.
I'm going to erase data on this board. So, I'm writing things in a bigger font so that everyone understands and the recording maybe कुछ font अच्छा है इसलिए अगर बार-बार मुझे board erase करना पड़ रहा है that's because I'm writing in a bigger font. So 1/n summation r is from 1 to n. I can write just this thing as, oh, okay. Let me write this with J. Just to not confuse that this is different than that, just to not confuse I'm writing this with J. I mean, although it doesn't matter, but just write a different variable that's better for clarity. Square. That's our function. Cost function fixed, model fixed, regularizer fixed, lambda. Once we have training data, we define what good lambda is. What's our goal? What is our goal? Now, having the error function formalized, what is our next goal? Tell me. We are going to find out the W's that gives this error minimum. We are going to minimize this function. This is a function of W. The only unknowns here are W. Make sense? And what is one way of minimizing a function? Any function? Under certain assumptions. Differentiate the function with respect to the unknowns, put it equal to 0, and solve. Because wherever the derivative is 0, their extrema exist. Those are the locations where either minima or maxima exist. Make sense? Yes. So we are going to differentiate this with respect to W0, put it equal to 0. We are going to differentiate this thing with respect to W1, put it equal to 0. We are going to differentiate this with respect to Wk and put it equal to 0. And we will be having d plus 1 equations. Why d plus 1 equations? Because we have d plus 1 parameters.
Yes.
starting from W0 to WD, we have D plus 1 parameters. So we are going to compute D plus 1 derivatives.
मैंडेटरी के हमारे पास डेरिवेटिव जब जीरो जब होगा तब वो लाजमी हम लोकल मिनिमा नाम नहीं होगा दिस इज द केस लाइक मतलब अपने ब्रेक फॉर्मेट के पहले मिनिमा होती है उसके बाद स्टेबल उसके बाद आगे एक्सेस हुआ
So the question really is this mandatory that the minima exists only where the minima or maxima exists only where the derivative is zero? The answer, I want to put this in another way. The maxima and minima will exist. जिस जगह पे maxima या minima है, वहाँ पे derivative definitely zero होगा. सही है? जहाँ कहीं derivative zero है, वहाँ maxima या minima का होना जरूरी है. So, make sense? Sorry?
अभी एक क्लासिफिकेशन प्रॉब्लम है
Yes. Or just to elaborate this point a little bit more, बहुत सारे फंक्शन ऐसे होते हैं जो डिफरेंशिएबल नहीं होते और उनके मैक्सिमा या मिनिमा को बाहर निकाल नहीं होते. So differentiation is not the only tool. I mean, it is a tool in smooth functions that are differentiable, that are convex, and there are several assumptions. If they are there, then go and differentiate and find out your minimum or maximum. If these assumptions do not meet and they hardly meet, then we have other techniques to do that, and that's a whole course of, mathematics known as convex optimizations. It deals with that. We will touch convex optimization a little. The portion that we need here, that's a whole theory, how to find out minimum or maximum function in several general situations. And just to link squared error with this, if I had not used squared error, जो minimization अभी मैं करने जा रहा हूँ, that would not have been that simple. अभी जो मैं करने जाऊँगा, the things will become very very simple just because I use square error. Change my error by here, जो मैं अभी आगे minimization करने चाहूँगा, that will become less simple. Make sense? Okay, good, great.
D feature is what?
The total number of features are D number of features. Should I move on? We all are on the same page. Should I move on? Okay, so I'm not going through the very painful process of, well, that is not that painful, but should I go through and differentiate everything with respect to all the parameters and then rearrange? And the other way is to write somehow the equation in vectors and matrix form and then do everything in, both ways are okay. In the earlier classes, मैंने आपको एक पैरामीटर के साथ डिफरेंशिएट करना सिखा दिया था. अभी मैं चाहूँगा ये कि मैं इसको किसी मैट्रिक्स या वेक्टर प्रोडक्ट के फॉर्म में लिख के दिखाऊँ and use some cheat sheet how to compute derivative of some function with respect to vector or matrices and things that become a little easy. Yes? Yes. Okay, so I'm going to write this in a vector form, in a vectorized form, a very nice and clean form. Number one, what you do is, the very first thing, what you do is, you concatenate a 1 on top of every vector by assuming the first feature is always 1. Why you are going to do that? I'm going to explain that in a bit. So let's say first feature of every vector is 1. Yes? And I'm calling this as, let's say, if x1 was the original data, I'm now calling it x1 hat with 1 appended at the top. Make sense? With this thing, you will notice that this thing becomes what? xi hat transpose w.
इसमें तो हमारे पास x से मतलब +1 ऐड किया था.
Oh, 1 ये कर दिया. ये 1 की is. So think we have this thing 1 x1 x2 xd, and then we have I here, and we have w0 w1 wd, and they are dot products. Now you should have got a point why we have placed a 1 here. हमने यहाँ पे 1 इसलिए लगाया है to make this nice dot product form.
Yes.
Otherwise हमें करना ये पड़ना था कि dot product plus W0. And that is, and this is more plain. Yes, no.
Yes.
If this is not okay, I should stop here. I can take the questions. If this is okay, I should move on. Is this okay with everyone? And this can already be written as W transpose W.
Yes.
No problem. Yes? So now we have this kind of situation. Our error with respect to W is 1 over n. By that I mean 1 is appended because it was column vector. By standardized हम vectors को column vectors ही लेते हैं तो हम taken transpose to make it row, and then we have W minus 5i square plus lambda W transpose W. Make sense? Yes, no? Is that okay? So हम कर क्या रहे हैं? गौर से देखिएगा, हम एक वेक्टर पकड़ते हैं, फीचर वेक्टर, उसको W से डॉट प्रोडक्ट लेते हैं और उस वेक्टर का जो लेबल था, उसके साथ उसका स्क्वायर्ड एरर कंप्यूट करते हैं।